Hello. Good evening, everyone. Am I audible? Okay. So let's start. So welcome you all to the fourth week of live mentoring session. So uh, so let's move to the first question today. So this is the question number 14 of GATE 2016 MT. So a schematic of X-ray diffraction pattern of a single phase cubic polycrystal is given below. The Miller indices of peak A is option A 210, option B 220, option C 222, and option D 310. So, uh, anyone want to approach how to solve this? Devendra or Vikas, anyone? You can try. Hello. Okay. hmm So, okay. So, what is X-ray diffraction? You all know, right? X-ray diffraction. What is X-ray diffraction? Okay. So, you are saying n lambda is 2d sine theta. This is Bragg's law, right? So using this formula, how can you solve this one? What this formula tells? This formula tells the condition of the relationship between the lambda and the theta and the d. So so this formula only tells that if this condition satisfy, then Bragg's law is satisfied, then only a diffraction will occur, right? But what is a diffraction pattern consist of? So in the x-axis it is intensity, and in the in the y-axis it is intensity, and in the x-axis it is 2 theta, right? So Bragg's law will only tell that at which for a certain fixed lambda value, which set of plane will diffract at what angle, right? So d and theta means, so this only tells, but here actually you need to identify what type of uh, crystal structure it is, because it consists of 2 theta. That 2 theta is depends on the Bragg's law, right? But intensity in the y-axis, it depends on several factors. So do you know what are the different factors means control the intensity of a XRD pattern? What are the different factors on which the intensity depends? Yes, angle is one factor. That angle is basically determines at which set of D plane will diffract at what angle. It is it has some effect on the intensity also, but there are other factors also. So okay, so let me tell you. So this intensity, the relative intensity depends on several factors. One is the l- polarization factor. Another one is Lorentz factor, and then structure factor, then multiplicity factor, temperature factor, and absorption factor. So these are the 6 different factors on which the intensity depends. Il- Uh, so you guys heard about these 6 different factors? What are these? Okay, okay. So because currently in which year you are? Okay, you are in the final year. Okay, so if I want to discuss all this factor, then it will take a lot of time. So also I will try to, if at the end, if time permits, I will try to explain all this factor. So just for the sake of for solve this problem, I will just tell that structure factor things, because this Lorentz and polarization factor and Lorentz factor together they called LP factor. LP factor. So I will just write the expression. So for LP factor is 1 plus cos square 2 theta divided by sin square theta into cos theta. So as you can see that this first two factor, it depends on the angle, right? So what you told, it is right that it also depends on the angle. So first two factor is depend on the angle. So and the third factor, that is the structure factor, it depends on the crystal structure. Your material is which crystal structure it is, either it is FCC or it is BCC or it is a simple cubic. So on this, so this structure factor is termed in terms of F, uh, capital F. So I will discuss much details in about this factor first to solve this question. And multiplicity factor is termed as small p. So later I will also discuss about this factor also. And temperature factor, it is e to the power minus 2m, and absorption factor is 1 by 2 mu. Okay. So this is the factor which basically give the relationship with the structure, which structure is your sample. So depending on this structure factor, you will get the different peak from different h scale set of plane, right? So these are the different h scale plane, 110 to 200 211. And so you need to find out the Miller indices of this peak A, right? So now uh, so these are the sequence of S value. S means h square plus k square plus l square. uh, so these are the sequence of S values. What you will observe in a XRD pattern, for simple cubic the sequence is 1 2 3 4 5 6 8, and so on. For body center it is 2 4 6 8, 10 12 14, like this. And for face center it is 3 4 8 11 12 16, and so on. So so let us first discuss how this range is coming actually. So structure factor is like okay. Before that, can you tell what is the X-ray diffraction? How means X-ray diffraction is happening? Like what is X-ray diffraction? First, you tell. Anyone? Devendra, are you there? Hello. Okay, so X-ray diffraction is basically scattering of X-ray by an atom or by an electron, you can say. So basically, what happens? X-ray is electromagnetic radiation, right? So when it falls on the sample, it interacts with the electron of the atom, and then it oscillates those electrons that is present in the atoms. So as you know that that oscillation of or accelerating or decelerating of a electromagnetic radiation will emit means electronic particle will emit electromagnetic radiation, right? So because of that, this oscillating electrons also scatter this X-ray in a different direction. Let's say this is a atom, set of atom it is there. So if let's say X-ray is coming here, so it is a electromagnetic radiation, right? So what will happen? It will set this atom into oscillation. So set the electron in this atom in the oscillation. So what will happen? Electron will oscillate like this. So for this, what will happen that it is that charged particle is accelerating and decelerating. So it will also scatter the X-ray. So this X-ray will scatter in this way. So this is the incident direction and this is the diffracted direction. So this angle is 2 theta, right? So now this is because of one atom. But what happens in your crystal system? Let's say this is a cubic crystal. So I am explaining in terms of cubic crystal because here it is mentioned that cubic polycrystal is there, right? So let's say this is a cubic crystal. So there are a plenty that different atoms at the different corners, right? So this when X-ray is falling, it will basically interact with all the atoms, right? So depending on the your structure, so that structure factor value will be different. So this structure factor value is written in terms of summation of Fi into e to the power 2 pi I divided by into h x plus ky plus lw, right? So let's say you are first let us consider bcc crystal, or you can first consider the simple cubic also. Let us first consider simple cubic, then we will go to the bcc, right? So in case of simple cubic, what is the unique location of an atom? It is the 000, right? So what is the xy z for of a simple cubic? Location of an atom is 000, right? Another one is 111, right? Sorry, 100. So like this only. So this is a one location. so so if you put the 000 here, what you will get, and another one is 100. So if you put here, what you will get, fi into summation means so it is 1 to n, okay? So fi, so if all the atoms are same, then you can write f in the place of fi. If all the atom is same, if the atoms are different at different corner, then you have to write in terms of the different atom. So let for the time being, let us assume that all the atoms are same. So it is f into e to the power 2 pi I into first put 0 plus 0 plus 0, okay, plus e to the power 2 pi I into let us put this 100. Okay, so 100 means only h will be there, other terms will be k into 0 means 0, l into the sorry, this will be z, l into z uh, means l into 0, that is 0, so only h will be written here. Similarly, if you put the other location of the atom, that is 010 and 001, then also you will get e to the power 2 pi I k plus e to the power 2 pi I into L, like this. So now if you put any values of the h, k and L, either it is odd or it is even, this value will be 1 only. So that capital F will be F into 1 plus 1 plus 1 plus 1, so it will be 4F. So at, so for all the HKL plane, that F is a, you have some constant value of this F, and as I told earlier that I is proportional to F square, right? So that I, it is depends on the structure factor. So this structure factor is F, and I is proportional to modulus of F to the power whole square. So this is for the simple cubic. So that is why it is you are getting the reflection from all HKL plane from all the plane you will get reflection. So that is why you can see for simple cubic it is 1 2 3 4 5 6, all are there. 7 is not here because with any combination of HKL plane, so h square plus k square plus l square, it will never be, the sum of this thing will never be 7. That is why 7 is not here. Now let us move for the body center cubic. Okay, then you will understand this thing. So for body center cubic, what will happen? Your atoms are on the corner and one atom at the body center, right? So what is the x, y, z value for this body center cubic? Sorry. So in this case, one unique x y z are 0 0 0. This is one. Another one is this one, that body center location, right? This is half half half. All the other atoms position you will get by translating this vector. Like if you add uh, half 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 with this thing, it will get this location. Again, if you add these things, then it will get miss. By the body centering translation, you will get location of all the atoms. So only these two location is enough to denote a body center cubic crystal, right? So let us apply this thing again here. So for body center, it is F is equal to summation of Fi e to the power 2 pi I Hx plus Ky plus Lz. Okay. So now for body center, again let us assume this all these atoms are similar. Okay. For a pure thing, pure crystal, it is not. Let's say it is not an alloy or something. So in this case, all the atom type of the atoms is similar. Then you can simply write it as F, and then you took the F as common. Then you put 2 pi I. So in the first case, it is H into 0 plus K into 0 plus L into 0. And then again e to the power 2 pi I H by 2 plus K by 2 plus L by 2. Right? So you will get F into e to the power 2 pi I into 0 means e to the power 0, right? Plus e to the power pi I into H plus K plus L. So e to the power 0 means 1. 1, and then it will be e to the power pi I into H plus K plus L. Now you have two conditions. One condition is when H plus K plus L is even. Another is H plus K plus L is odd. So when it is okay, so let us write here. So first let us check for when H plus K plus L is even, what will be the situation? If H plus K plus L is even, that means let's say it is 2n. So in this case it will be F into 1 plus e to the power 2 pi I into H 2 pi I into n, right? So e to the power 2 pi I into n. So this will be always 1. We got it. E to the power 2 pi into n. When this is even, you will get a multiply of 2. So 2 pi will be here. So e to the power 2 pi I will be always 1. So so capital F will be 1 plus 1. So it will be 2f. So if it is 2f, then what will be the intensity? I will be 2f whole square, right? Because I is f square. I is capital F to the whole square. So it will be 2f to the whole square. So 4f square when H plus K plus L is even. Now let us see when H plus K plus L is odd. So let's say in the second case, when H plus K plus L is odd. So let's say this is 2n plus 1. Then what will be the f? F will be small f into 1 plus e to the power pi I. So let's say it is 2n plus 1. So pi I, so hk plus k plus l is 2n plus 1. So it will be multiplied of 2n plus 1 into pi. Okay. So this will be always minus 1. So this value is minus 1. Sorry, this is minus 1. 1 minus 1. So what will be your structure factor then? It will be 0, right? So what will be your intensity then? Intensity is proportional to f square. So your intensity will be 0, right? So when H plus K plus L is odd, your intensity is 0. I is 0. So for the H plus K plus L odd value, you will not get uh, you will not get any reflection. So that is why you can see that it is 2, 4, 6, 8, 10, 12, 14. All the even value is there, right? Similarly, you can calculate for the phase center. So I am not calculating this part. So you can do in your home, so how to calculate it. So, and then in the next session you can show me also if you have any doubt. So for the FCC I'm just telling you the location of the XYZ. For FCC, what are the different location? One is 000, that is the corner atom. Let us draw the FCC first. So 8 atom at the corner and 6 atom at the face center, right? So this is, let's say, one atom at the corner and other three atoms at the face center position. And so if you do the translation of this face centering translation, you will get all the other location of the atom. So only this four coordinate is enough to uh, denote FCC location of the atoms in a FCC. So okay, so this four coordinate is the location of the XYZ for FCC. So again for FCC you have to put first here as 000. Then in the second case you have to put half 0, and then 0 half and then half 0 half. So total four terms will be there. In case of BCC only two location was enough, so that's why only two terms was there, right? In case of FCC four terms will be there. So and if you calculate, then you will get that for FCC the condition will be either HKL, either uh, H comma K comma L will be unmixed. Unmixed means either all are even or all are odd. So then you will get this series for FCC. So now let us see our problem here. So in our we are given a diffraction pattern. So that is one. So first peak is 110. So what is the age value for the first peak? Okay. Before that, anyone has any doubt on this? Up to this, do people all understand how I am calculating the structure factor? How we are getting this HKL, this range, this sequence of age values? Mm-hmm. 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 Ha. 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 Okay, I am writing here in terms of summary then. Okay, just then it will be clear, I think. So this is the thing that I show you how you are getting this thing, that means how you are getting this, what table you are saying na. Let's say for cubic, then BCC, and then FCC. Okay, so you are saying for cubic it will be all HKL. For BCC it will be H plus K plus L should be even, and for FCC it will be unmixed. Unmixed means either all odd or all even. So this is the final thing that you have to remember, right? But I was just explaining how you are getting this thing actually. How can you say that for BCC it will be all even, for FCC it will be unmixed? That part I showed here actually, right? So uh, let us first discuss that intensity part once again. So as I told you, right, intensity depends on several factors. First factor is Lorentz polarization factor, that is 1 plus cos square 2 theta by sin square theta cos theta. Then second factor is structure factor, that is F square. Third factor is small p, and then it is temperature factor is e to the power minus 2m, and the absorption factor is 1 by 2 mu. So now let's say all other things are constant. If all other things are constant, then you can write I is equal to k into only this structure factor term, right? F square. Now I showed you that how this structure factor is coming. Structure factor is summation of this thing. Okay. So here you can see that for BCC it came. So this part you understood or not? Or should I explain it again? So this part, this F calculation, structure factor calculation part. Mhm. Okay, actually, to solve this question, you don't need to know that how you are calculating this structure factor. If you just remember this thing, na, this table, you can solve this question. But I was just trying to explain that how this thing is coming. That is why. Okay, so later I will just tell you that how to simply solve this question. So first, that's why I am just giving the brief introduction of this thing. Uh, so okay, so I am repeating this thing again. So let us draw the BCC crystal again. So there are 8 atoms at the corner and 1 atom at the body center, right? So now for BCC, that okay, first let me write the F expression for the F. F is summation of I equal to 1 to n f I into e to the power 2 pi I hx plus k l plus ky plus l z. So this HKL are the Miller indices and this XYZ are the location of a different atom, right? So now for BCC, what are the different location of the atom? One is 0, 0, 0. Another one is half, half, half. And I I wrote these two location only. Now you also can write all the other location, right? But it is not needed to write all the location because let us assume that we want to find this location. Okay, so now we know this 0, 0, 0 location and we know half half location. Now all the other location you can find out by the body centering translation. What is the body centering translation is this half half half. See, if you add this half 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 will with the this atom, let's say, so the location of this atom is half half half. Now you are adding the body centering translation, that is half half half, so you will get it is 1 1 1, right? That means this location you got. Now again you add half 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 with this thing, you will get this other location here. Okay, so this way. And now if you so all the other location you will get. Okay, let uh 1.5 plus 1.5 1.5. So in this way we will get all the other location, like this one location, this location also will get. So for body, if you do the body centering translation, so you'll get the other location also. So for BCC, what is the thing that only two XYZ is enough to denote this body centering thing. So you no need to write the all the location of the atoms. Only these two location if you know. So this is basically uh, express a body center cubic crystal. So now I am putting this XYZ value. This is the XYZ basically location of the atom in this equation. So in this case we have I1 and 2, two location, right? So one is F into e to the power 2 pi I. So in this case H. So first case X is 0. So H into 0 plus again K into 0 plus L into 0, right? And then second case is F into e to the power 2 pi I H. X is 1 by 2, that is, so it will be H by 2. This will be K by 2 plus L by 2, right? So now if you take the F common, so then it will be E into 2 pi I into 0. So this part is 0. So e to the power 0. And this will be e to the power pi I into H plus K plus L. So now you know e to the power 0 is 1, right? That part you know, right? So e to the power 0 is 1. So now what is e to the power I theta? You know what is this expression? How can we write? E to the power I theta means cos theta plus I sin theta, right? So now this is e to the power I. So that means e to the power I into pi into h plus k plus l. So it will be cos of pi into h plus k plus l plus I sin of pi into h plus k plus l. So now if you put h plus k plus l as even, let's say h plus k plus l is even, that means 2n. So then what will be the this thing? This will be cos of 2n 2 pi n or 2n pi, okay, plus I sin of 2n pi. So what is cos 2n pi? Cos 2n pi is 1, and I into sin 2n pi is what? 0. So what will be this thing? This will be then 1, right? So then you can write f into 1 plus 1. So you will get 2f. So in this case you are getting f as 2f's. So intensity will be 4f square, right? Now if you put h plus k plus l is odd, that means 2n minus 1 or 2n plus 1, let's say. So so in this case what will be this thing? E to the power I into 2n plus 1 pi is equal to cos of 2n plus 1 pi plus I sin 2n plus 1 pi. What will be this value? Cos 2n plus 1 pi means how much? It is minus 1, right? Cos pi is what? Minus 1. Cos 3 pi, what is the value of cos 3 pi? It is also minus 1, right? And sin pi or sin 3 pi, sin 5 pi, this is 0. So you will get this is minus 1. So in this case what will be the when it is even, then you will get this. When odd, you will get 1 minus 1, so that means 0, right? So that time intensity will be 0 when all the odd. So that is why when h plus k plus l is even, then only you are getting the reflection. When h plus k plus l is odd, that time you will not get any reflection. So that is the reason. Okay, so now you got it, how you are getting this structure factor thing, that if calculation, right? You got it now? Any doubt you can tell me right now also. Anywhere you are facing difficulties. So I'll just tell this thing, because if someone forgot this thing, na, if they can also try to visualize this thing, how this table is coming, or else if you just remember this table, you can solve this question. So now let us go back to this question. So this is the sequence, and we got based on this thing, this formula for simple cubic, all HKL for body center, H plus K plus L should be even, and for FCC it is unmixed. So based on these three condition, we got the sequence of this. So now let us see our problem. In our problem it is mentioned that first peak is 110. So what is the value of S for the first peak? S means what? S means h square plus k square plus L square. So what will be S in this case? Why root 2? H square means 1 square plus k square means 1 square plus L square means 0 square. There is no root. You can see S is h square plus k square plus S square. So this will be 2, right? And what will be the S for the second peak? It will be 4. For the third peak, 6. So now you can see the trend. Which trend it is following? 2, 4, 6. That means 2, 4, 6. So now you can identify this is the XRD peak of a BCC, right? So what will be the next thing? S value for the next will be 8. Okay. So 8 means, let us see the our option. What is the S value for first option? 4 plus 1, that is 5, right? What is the option for second? It is 2 square plus 2 square. This is 8. Option, got it? So what will be the answer? Option D. Yes, so 8 will be the answer, right? So option B is correct, because option B you are getting that thing 8. For other, you can see for option A that S is 5, option C it is 12, option D it is 10. So for option B it is 8. So what will be the Miller indices of this peak? It will be 220, right? So no need to bother about all this calculation or thing. If you just remember this thing, you can directly calculate and this value. Okay, I was just trying to explain that if someone forgot this table, then at least they can visualize how they are getting the peak from different set of HKL plane. Okay, so let us then move to the next question. It is clear, right? Mhm. Okay. Mhm. Okay, okay, wait. Okay, I'm writing in this blank page. So for FCC, what was the condition? HKL should be unmixed, right? Means either all are odd or all are even. So if H plus K plus HKL is unmixed, so let's say should be the condition? First 0 0 0. So that is not a peak basically. So then it is 1 0 0. Okay. So in this case, 1 0 0 is mixed or unmixed. One is even, odd, and 0 is considered as even. So this peak will not be there. Okay. So what will be the next peak? 1 1 0, right? So this is also, you can see that this is odd, one is odd, and one is odd, and this is 0 is even. So this peak also not possible for FCC. So what is the next? 1 1 1, right? So here you can see all the HKL are odd. One is also odd, one is also odd, one is also. So this peak is possible. So what will be the first peak for the FCC? 1 1 1. So what is the S value for this peak? 1 square plus 1 square plus 1 square. This is 3. Now what may be the second peak? Say 1 1 1 is complete, then it may be 2 0 0, right? Means you are going one by one. First you are completing all the one set, and then you are going to the two series. So from the two series, start from the 2 0 0. Like here we started from 1 0 0. So 2 0 0, you can see that 2 is even, 0 is also even, and 0 is also even. So that means this peak also possible. So what is the value of S value of this second? So S1, let's say S2. So it is 2 square plus 0 square plus 0 square. So that is 4, right? So now what maybe the next bit? 2 1 0. It is not possible because 2 is even, 1 is odd. So this peak is not possible. Again 2 1 1, it is also not possible, right? Then 2 2 1, it is also not possible, right? Then 2 2 0 is possible. Sorry, 2 2 0 is possible, right? Because 2 is even, and 2 is even, and 0 is even. So what will be the third peak then? Third peak will be 2 2 0. So 2 square plus 2 square plus 0 square. So what is this? 8. So now we are getting it. First 3, then 4, then 8. So we are so this, because of these things we are getting this range, this sequence actually. 3 4 8, then 11. If you goes on like this, you will get this thing. Okay, you just try to visualize. Okay, if you have any doubt, you can ask me in the next session also, no problem in that. Okay, and you also, by the time, you also read these different factors also, that how this intensity is depending on the other factor. Okay, sometimes the question might be asked from these other factors also. Okay, so better to know all these factors. Okay, so now let's move into the next question then. So this is a very simple question. This is a mostly involve the mathematics only. So the question is, the grain sizes measured at 5 location in an alloy sample are 16, 14, 18, 15 and 13. Okay, so what will be the mean, median and standard deviation of the grain sizes respectively are, these are the different options. So what is average basically? Average is basically the average value of this given number, so that easily we can calculate. Mean is basically the average number, average of the given number. So what are the different given number we have? 16 plus 14 plus 18 plus 15 plus 13. So these are the different number we have, and how many are there? 5. This is divided by 5. So what will be the mean? Can you calculate and let me know? 15.2, right? Okay, so it is coming 15.2. So right now you can cross out this option because it is 15.8. So now let's move into the next thing. Median. What is median? You know what is median? What is median? Hmm? Ha, exactly. First you have to arrange it either in the ascending or in the descending order. Then you have to you will get the median, that middle value. So first let us arrange in the ascending order. So smallest value is 13, right? So first is 13, then 14, then 15, then 16, then 18, right? So what is the middle value? That is 15. You are having odd number, right? If you have even number, then you have to take the average of the middle two value. So in this case, just simply that middle value will be the median. So what will be the median? That will be 15. Median is 15. So now you can cancel out this option also because it is 16, right? Now let's move into the next thing, that is the standard deviation. So what is the standard deviation? Standard deviation is basically that it basically measures how much your data is dispersed or how much deviation is there from the average value. Okay. So this is the formula for the standard deviation. Is it visible, right? Ah. So now we can calculate the standard deviation also. So standard deviation is for, let's write here, sigma is equal to root over of summation of these things. So xi minus x bar. Xi means let's say 16 minus 15.2 whole square plus 14 minus 15.2 whole square plus 18 minus 15.2 whole square plus 15 minus 15.2 whole square plus 13 minus 15.2 whole square, and n minus 1 means 5 minus 1. Can you calculate this one? How much? How much it is coming? You think this is coming 14.76 divided by 4, right? So it is coming 1.92. Is it? Yes, it is coming 1.92. So what will be the answer then? So this is the answer, right? Option B. You got it? Hello? Are you there? Okay. So got it right? Mm-hmm. So should I then move to the next question? Okay. Huh. So this is the question of thermodynamics. So this is the question number 32 of GATE 2016. So the question states that the change of standard state from pure liquid to 1 weight% of silicon dissolved in liquid iron at 1873 Kelvin is expressed as silicon in the liquid is equal to silicon 1 weight%. Given that the activity coefficient of silicon at infinite dilution is 10 to the power minus 3. So what will be the standard Gibbs free energy change in kilojoule for this equilibrium? Okay, so this is basically this equation is showing the change in standard state from pure to 1 weight%. So that means you are diluting your solution. So pure means it is standard state, uh, and for a solution your standard state is described by at 1 atom percent, sorry, 1 weight% is described as the standard state in the infinite dilution for a for the solution. Okay, so we need to calculate the standard Gibbs free energy change, and what are the data is given that activity coefficient of silicon at infinite dilution is given, that is gamma naught is given. This is 10 to the power minus 3, right? So now what is the standard Gibbs free energy change? Standard Gibbs free energy change will be G naught of product minus G naught of reactant, right? So G naught of product means G naught of this thing. G naught of silicon 1 weight% minus G naught of silicon liquid or pure. Okay. So how you can write G naught in terms of activity? You can write in terms of activities. This is RT ln activity of silicon 1 weight%, right? Minus RT ln activity of silicon in liquid, that is in pure form. So then if you take RT common, it will be like ln of activity of silicon 1 weight% divided by activity of silicon liquid in pure state. So now you know Henry's law, right? What Henry's law, what it states? It states that in at infinite dilution, activity is gamma naught into your XA, that is mole fraction. This is at infinite dilution. And what is the activity of a pure component? Activity of pure component is 1, right? So activity of pure component is 1, and activity at infinite dilution, it is followed from the Henry's law. Henry's law states activity is equal to gamma naught, that is activity coefficient, into x of a. So you have to put here gamma naught into x of silicon, right? So now this gamma naught value is given. Yes, and x of silicon is you have given in the terms of weight percent. So you have to convert it in terms of mole fraction, right? So you know how to convert it. Yes, so 1 weight percent silicon is given. So 1 weight percent. Now what is the atomic number of silicon? It is 28, and atomic number of silicon is dissolved in which in iron, right? Okay, so silicon is dissolved in iron. So that means iron atomic number of iron is 56. Okay, so now we want to convert in terms of mole fraction. So it will be 1 weight divided by 28. That means 1 by 28 mole of silicon divided by 1 by 28 mole of silicon plus how much iron is there? 99, because 1 out of weight percent silicon is there. So 99 weight percent of iron will be there. So divided by 56. So this will be your atom percent or mole fraction of a silicon. So can you calculate it and how much it is coming? Check. Are you getting this value? 0.0198. Okay. So you got XSI. Okay. So what is delta G naught then? It will be RT ln of gamma is 10 to the minus 3 into this is X silicon means 0.0198. Now R is R value R is 8.314 and T is given. T is 1873, right? So R is 8.314 because you have to calculate in the kilojoule. So you have to use the value of R in the joule per mole per this thing. You cannot use the R in the calorie or this unit. So that's why you need to put 8.314 here. T is 1873 and then ln of this thing 0.0198 into 10 to the power minus 3. Now if you calculate, you will get the standard free energy change for this. How much you are getting? Okay. So it is coming minus of this, right? You will have minus sign 168,643.41 joule. right? So if you convert in terms of kilojoule, then you have to divide it by 1000. So it will minus 168.64 kilojoule, right? So this will be your answer, minus 168.64. So what will your answer is minus 168.64 kilojoule. Okay. So do you have any doubt in this question? Okay. Okay. So as already the time is over, so I am not picking up new question today. So if you have any doubt from the any of the previous questions or these things, you can ask me. Or if you have if you are facing any difficulties in any of your subject for preparing gate, you also can ask your doubts also. I will try to clear those. Yes. This XRD things or the fuel energy. Okay, this one, right? Okay. Okay, so you want to write it or? Oh, okay, okay. Okay, I am also uploading this recording of this live session in my YouTube channel also, because we are also instructed to upload there. So that later you guys can follow those video also if you forgot anything, or it is in my name only, Suman Sadhu. So I can share the link also. Just a second. Yes. Okay. Okay. So I'm sending the my mail ID also in this chat box. So you can mail me anytime. No problem. I will reply there only. Okay. So if you have any doubts regarding anything, you can ask me. So next, from the next session, I will solve the question from the GATE 2014 papers. Okay. And I think one more question is left from GATE 2016 that I will cover, and other question will be from the GATE 2014 paper. So before that, if you you can try to you can read those concepts also, so that it will be easy for you to understand those things. And yes. Okay, so in and for this XRD things, this different structure factor as I told. So this you can read from the BD quality also. There it that expressed in a very easy way actually. So you can understand from there. Because if I want to explain all this factor now, it will take lots of time. Because this polarization Lorentz factor itself will take 1 hour at least to prove these things and all. And so just in brief I can just tell you, but that will not help much. So it will be better to clear the idea, or clear your concept. So in this question you will write that if you just know this thing, this table, you can solve this question, that the age scale is even, and this table, if you know, you can solve this question. But just to show that how this condition is coming, that you didn't know, right? How this thing is coming, you just know that this is the condition. So this concept also is, it is also mentioned there in this book. So that part also you can write, you can read. So uh, this thing actually I did for the pure or alloy thing, pure crystal or alloy. But if some crystal is in the ordered phase, that time this f value will not be same. So in that time you cannot take the f as common. So that time the different scenario will arise. So in this case for BCC crystal also, you may get some superlattice reflection because of the ordering. So this part is also there. Sometimes this type of question may be asked in the gate also, right? So for that you should read those part also. So it will help you also to prepare in your uh, for gate. Do you have any other doubt from any other things? You can. Okay. Okay, then we'll close this session for today. So we'll meet in the next session on the next Friday. Okay. Okay.